We're going to do some more practice with our DTV and VAT and some couple combo situations where you have to use both of them to solve for different things. And well, it's still the same basic ideas, just a little bit different scenarios. So we're just going to start with a guy running here, and maybe he's running at 5 meters per second, and he's going to speed up, and maybe he goes, let's say he goes 28 meters. And he's able to do that in 4.2 seconds. And what I would like to know is what was his acceleration? Okay, well, I'm not really going to worry about the acceleration right now. I'm going to worry about what can I find with what I'm given. I'm going to look at the quantities that I'm given because they sort of dictate what I can and can't do. So I've got an initial speed, and I'm going to map out my speeds. I know he starts at 5 meters per second. He goes up to something that I don't know. And of course, I'll eventually need to know that final speed to get the acceleration. But in terms of what I do have, I have distance and I have time. I've got my D and I've got my T. And with distance and time, I can find average V. So average V is distance divided by time. So if I use that 28 and divide it by 4.2, I can find out the average speed of my runner. So if I do that, I will get an average speed of about 6.7 meters per second is my average speed. Now, of course, my average speed in my whole V situation belongs right in the middle. So I know right in the middle is 6.7 meters per second. So now that I know that, I can use that to help me figure out the final V. So there was an increase of 1.7 between here and here, so that means it's going to be another 1.7 from there to there, which tells me that the final speed at the end must be like the 6.7 plus 1.7 gives me 8.4. So the final speed here must be 8.4 meters per second. So that's how fast he got up to. All right. So now that I know that, I can find my change in V, because my change in V goes from 5 to 8.4, he sped up by 3.4 meters per second. Of course, the change in V comes in handy for my accelerations. So if I want to know the acceleration now, acceleration is change in V over change in T. Well, I've got my change in V already. That's the 3.4. And then I just have to divide that by my time, which is just the 4.2. Just divide those two together, and I'll get an acceleration of about 0.81 meters per second squared. Okay, so there's his acceleration. Okay, all right, well, let's clean this up and let's try a different scenario. Okay, well, let's see. Suppose we've got, let's do a plane, and let's do like an old-fashioned plane too, like World War II type plane, or not World War II, World War I type plane. It's a like bi-wing type plane, propeller in the front. Okay, something like that. All right, so we've got a little airplane flying along. And let's say it's flying at, let's go 20 meters per second. And it flies at 20 meters per second for 6.5 seconds. That's what it does first. Then what it's going to do is it's going to slow down. It's going to decelerate. Let's say it's going to decelerate at 2.8 meters per second squared for, let's go with 5 seconds. Okay, all right. So that's actually, the plane's actually going pretty slow, but whatever. We're just practicing a question here. So it's going 20 meters per second for 6.5 seconds, and then it's going to decelerate at 2.8 for 5 seconds. Okay, now I'm not even going to give a question. I am just going to start just finding stuff. That's all I'm going to do is just start by finding stuff. So I'm going to go to my beginning part, and I've got my plane. My plane's going 20 for 6.5. So it's not speeding up, it's not slowing down. I've got the speed and I've got the time. So with speed and time, I could find distance. So I'm going to do that. I want to find out the distance during the first part. So my first distance would be equal to my first time multiplied by my first speed. So I was going to multiply those two together, the 6.5 and the 20. And that gives me a distance of 130 meters. Okay, so that's all really I can solve for the first part. So I'm going to go to the second part. What do I have in the second part? Well, I've got an acceleration and a time. Well, with an acceleration and time, I can find a change in v. So I'm going to find the change in v in my second part. And subscripts, yeah, the subscripts are important. So the acceleration times my second time, not the 6.5, but I'm going to use that 5 seconds. So I've got the 2.8 and I've got the 5, and I can multiply them together. So I've got the 2.8 times the 5, and that gives me a change in v of 14 meters per second. Now, I know it's slowing down because it's decelerating, so I know it's actually going to be a negative 14. It'd be a negative acceleration, so negative 14. So let's see what I could do with that. Well, I have the change in speed, but I also have the initial speed. So I'm going to map out my speeds like I like to. So it was going 20, and it went 20 that entire time. That was a constant speed. Then it got into the second part, and the speed dropped apparently by 14. Well, if it dropped by 14, at the end here, it's only going 6 meters per second, which seems pretty dangerously slow for an airplane. But now I've got all my V's from beginning to end. I got starting with 20, keeps the 20, and then it goes to the last part. The change in V was 14, so it ended up only going 6. Well, with that, I got from 20 to 6. I could find the average V for my second part. So if I found the average V for my second part, that would just, it's going from 20, it's going to 6. And right in the middle of those two, you can add them up, divide by 2 if you want to, doesn't matter. It's going to be 13 meters per second. So right in the middle here is 13 meters per second, and that's my average V during the second part. Now notice I'm actually putting the quantities on the side they belong. So I've got all my initial stuff right here, and I've got my second part stuff over here. I like to put my stuff where it belongs in the diagram and in the picture. All right, so now that I have my average V, I can find my distance because I know my time for the second part. I could find out the second distance. So D2 would be my second time multiplied by my second average speed. Because the first part had a constant speed, this one's got an average speed because there's an acceleration. So I'm going to use the time, which is 5, and the average V, which was 13, and if I put those two together, I get 65 meters. All right, so now I've got that. Well, I've got my two distances. I can easily put those together, and my total D would then be equal to 195 meters. Okay, well, let's see, total D. Well, you know what? If I've got my total distance and I've got my 2 times, I could actually find my average speed for the entire situation. So if I wanted to find my total average speed, I could use my total distance, and I could use my, not my TOF, but my total time. Yeah, that one actually looks like, there we go, that's a little better. Oops, wrong tool. That one, here we go, total T. So my total distance was 195. My total time, let's see, I've got 6.5, and I've got 5 seconds, so that'd be 11.5 seconds altogether. So I'll do that 195, and I'll divide that by 11.5, and that gives me an average V of 17 meters per second, which would also be the average velocity since it never went backwards or anything like that. Okay, so sometimes when you have questions like this, it's not about what you're looking for. You just want to start solving for stuff, and one thing will lead to another, and eventually you can solve the entire situation, which we just did. Okay? All right, so let's try something else. All right, well, suppose we've got, we'll draw some grass or something like that, and then over here, I'm going to draw some mud. And a little more grass over here. Okay, and over here we're going to draw. Here we go. It's one of those little electric toy cars kids have nowadays. Well, they've been around for a while, but if there's little toy electric vehicles, And there we go. So we got a little kid in there driving his little toy vehicle, driving along the grass, and see some mud. Okay, so they're cruising along, and I mean, they're not the super fastest little vehicles, but not too bad sometimes. And he's cruising along the grass. He sees some mud, and he wants to try and get through the mud. Okay, so to start off with, we'll say that he's just traveling at 2.5 meters per second, and he's going to, well, I say step on the gas, but they don't use gas, so he steps on the electricity, I guess. And let's say he accelerates at 0.8 meters per second squared for 6 seconds before he gets to the mud. So right there. So that's how far I can accelerate. So I'm just trying to go as fast as he possibly can before he hits the actual mud itself. All right. Now, when he gets into the mud, he gets stuck right there. He doesn't quite make it up. He gets stuck at the very, 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 very end of the mud. And let's say that the mud was like the mud patch, how far across it was. Let's say there was 2.5 meters of mud. Okay, so he's stepping on the gas. He's going along. He speeds up as best he can, and then he hits the mud, and he gets stuck at the very end. He makes it across the mud, but he sort of gets stuck at the end there. So I want to know is what is the acceleration that the mud supplies in order to stop him. Okay, so there's a few things going on here, but let's just look what we've got, take it one part of the time, and just start by finding stuff. So I'm just going to go to the very beginning, see what I got to work with, and see what I can do. Well, let's see. I have got an acceleration, and I've got a time. So I know with acceleration and time, I can find the change in v in the first part. So I can do the 0.8 times the 6 to get a change of v of 4.8 meters per second. So that's the change in v for the first part. Now I know that he started at 2.5. So he started at 2.5, went faster, and it went up by 4.8. So I can find out how fast he was going when he hit the mud because I just have to add those two together. So if I add those two together, I got the 4.8 and I got the 2.5. That's going to give me 7.3. So he's going 7.3 meters per second when he hits the mud just by adding the initial v and the change in v together. Now I know he gets across the mud and he gets stuck. So he gets across the mud and gets stuck. So here he's going 0 meters per second because he's stuck in the mud and stopped. All right. So let's see if I can use that to help me out in the second part. So what do I know about the second part? Well, I've got the distance and I've got the v's. Well, if I got the 7.3 and the 0, I know the beginning and end v's. I can find the average v for the second part. So the average v for the second part would just be, the halfway between the 7.3 and the 0, or just cut the 7.3 in half, and the average speed must have been 3.65 meters per second. Okay, so I've got the average v for the second part, but I've also got the second distance. If I've got the second distance and the second average v, I can find the second time. So the time to go through the mud would be the d2 divided by the average v number 2. So that would be 2.5 meters divided by 3.65. So we got the 2.5, we'll divide that by 3.65, and it's only 0.68 seconds. So it's pretty just stops really, really quick, which means the acceleration can be pretty high. Okay, so do I have enough to find the acceleration? Well, let's check on that. For acceleration, I need the change in v over change in t, and this will be my second part. Okay. So do I know my change in v for the second part? Well, he started at 7.3 and went to 0. So obviously it dropped by 7.3. I know the time is 0.68. So if I just divide those two out, so I get the 7.3 and divide that by my time, I'm going to round off a little bit. We got an acceleration of about negative 11 meters per second squared, which is a pretty good acceleration for something like this. That's gonna jar them pretty good. Okay, so again, find stuff one thing can lead to the other, and eventually you can solve the entire thing. All right. All right, well, let's clean this up and try some, let's try another question. Okay, so for our last question, let's try this. Let's get some ground going on here. I don't know, let's come up with something here. Let's, all right, let's go with, get some kind of, all right, this, color in here. There we go, some kind of robot. There we go, some kind of robot there. All right, some kind of weird creepy robot. And over here, we are going to have, let's use that one. Okay, so here we are going to have Captain America. Why not? All right, so Captain America, and what he's going to do, it's going to be holding up his shield here. Like that, something like that. I'll go blue in there. All right, so good enough. Okay, so our evil robot here has got like a little missile thing. And he's going to shoot a little tiny missile at Captain America, something like that. Okay, and the missile is going to come along, and it is going to hit his shield, and it is then going to bounce off before it explodes. Okay, something like that. All right, so let's get into some logistics here. So the missile here starts obviously at rest over here. So the missile's at rest, and then it's going to fire across, and the missile is going to accelerate at, let's go with 28 meters per second squared for 1.4 seconds. Okay, then it hits his shield, and after it hits the shield, maybe the boosters are all out, doesn't matter. This part over here, it's going to move at a constant speed, all right, for 0.35 seconds before it explodes. Okay, now what I want to know for the situation is what's the average velocity for the missile before it explodes. Okay, so we got it coming in, deflects off a shield, and let's see, we got to have an little angle here, good old-fashioned angles. We'll say it's 50 degrees until it explodes. All right, so let's just start by finding some stuff. Don't worry about all the fancy schmatch stuff. Let's just worry about finding stuff. So let's go to the beginning part. I've got acceleration and I've got time. So, of course, with acceleration and time, I can find the change in v for the first part. So I've got the 28 and I got the 1.4. So if I got the 28 meters per second squared times 1.4 seconds, I get 39.2 meters per second. All right, so I'll change color. So I got 39.2. So here it's going 0 meters per second. And by the time it gets all the way over here, it is 39.2 meters per second. And it keeps that 39.2 during the second half because I said constant v for the second part. Okay, so I've got the change in v, I've got the v's for the first part, I've got the acceleration, the time, but I could also use the distance for the first part. So let's find the distance for the first part, then I've got everything. So I would need the average v for this, and of course it's starting at 0, so that's a little bit easier. So my average v for the first part is 19.6 meters per second. And during the second part, the v is constant. It's just staying at 39.2. But first part, average v, 19.6. So if I have that, I can find the distance for the first part would be the first time multiplied by the average speed for the first part. So I've got the 1.4 seconds. I'm going to multiply that by the 19.6, and I get 27.4 meters. Okay, I've now solved for, I got the V's, the T, I've got the D, I've got everything for the first part. So now I'm going to move on to the second part, which is actually easier because the V is constant. So I've got all the V's for the second part. I've got the time. Really, the only thing I can solve for over here is the distance for the second part. So if I find that second distance, my second time, of course, is 0.35 seconds. The V is constant at 39.2. So if I do the 39.2 and I multiply that by the 0.35, that second distance is 13.7 meters, and that's how far it went before it blew up. Okay, so I got all the bits and pieces. All right, so now it says I want the average velocity. Okay, well, for average velocity, I need displacement and time. If it was distance and time for average speed, a little bit easier, but I want velocity, so I need displacement and time. So I've got to piece together my displacements. Well, let's see. My first one, it went 27.4 meters this way. Then it went off at an angle at 50 degrees at 13.7 meters. So I've got to break this thing apart and put the vectors together. So I'm going to do a little XY chart action and piece it together. So the first one there is 27.4 and 0 because it's all in the X direction. But now I need to break apart my second vector. So I got 13.7 cos 50 for the X component, which is 8.8. And I'm going to do a 13.7 sine of 50 to get the Y component, which is around 10.5. Okay, so I've broken them all apart. Now let's put them together. So that's easy, 10.5 over there. And I've got the 27.4, and I'll add the 8.8 for my total X component, which is 36.2. Okay, so now that I've got my total X's, my total Y's, I'll make my new triangle. So my total X was 36.2, then it went up 10.5, and then I will solve for the hypotenuse, which goes all the way across, something like this, using my Pythagoras and my trig. So if I take those two measurements and I put them together, I will get a hypotenuse of around, not too bad, it's 37.7 meters. And if I do the angle at the 10½ divided by 36.2, because I like to use tan theta to solve for my angles for this type of thing, we're looking around 16 degrees. Okay, so my displacement for the missile is 37.7 meters at 16 degrees. Okay, so that's what I want to use for my velocity. So for my average velocity, delta D over delta T, my displacement was 37.7. Total time altogether, I've got the 1.4 seconds. I got the 0.35 seconds. That'll be 1.75 seconds altogether. So I'll do the 37.7, divide that by the 1.75, and I get an average velocity of 21.5 meters per second at the exact same angle of the displacement, which is 16 degrees. So that would be the average velocity of my missile. Whew. Okay, so lots of stuff here. The average velocity when things change direction are definitely one of the longer type of basic kinematic questions, but there's lots of steps, but it's all just about little things. Find one small thing tied to something else. Find another small thing tied to something else, and just keep on finding stuff. And when in doubt, just find everything you can, and eventually you'll probably end up getting to the answer that you're looking for. Okay, so there's some more practice putting DTV and VAT together.